EACC Math, Lesson number 9, Working with Linear Equations. The term linear means straight line. So a linear equation, when you graph them, would be a straight line. So down here we have a linear equation. Now that's real important in modeling. And we're not going to get into that today. We're just going to look at simply solving some basic linear equations. But we're leading into the modeling part. Here's another example of where we could use linear equations to model. Here's the total personal income for these years, 1986, 1986 to 1997. You notice that if I were to draw a line, it would be pretty much a straight line. So this would be, we could model this linearly. So it looked like something like this, y equals mx plus b. We could come up with the equation for that line. And again, the important part is we can use that equation then to make predictions for the future. For example, well, what's the predicted personal income for the year 2021 going to be? Here's another basic linear model. It's a simple converting Celsius degrees to Fahrenheit. And again, you can see it's a nice straight line. And again, we can use this to say, okay, at a certain degree Celsius, what is it in Fahrenheit? Modeling real world situations. Okay, so today we're just going to look, though, it's just solving some basic linear equations. And what we mean by solving is we want to get, given a linear equation, how do we get the variable by itself? How do we find the value of that variable if there is one? Some equations have no solutions, some have infinite solutions. Ours today will have a basic solution. Okay, when you're solving linear equations, you sort of undo the operations around the variable. In other words, if you have something subtracted, you're going to add that to get rid of it. If you're multiplying, you're going to divide to get rid of it. And we've got to think in terms of a balanced scale. The equal sign is our fulcrum here. And whatever we do to one side of the scale, we've got to do to the other side to keep the balance. So as we work through this problem, you notice what they've done here. 5x minus 2 equals 13. We add 2 to begin with to get rid of the negative 2. And then we divide both sides by 5 to get rid of the 5 times the x. And there's our solution. X is equal to 3. Now, the next step is ultimately important. Be sure to check your answers, especially if you're taking any kind of a placement test. It's very simple to do. You just use simple substitution. Put the value in for the variable, work out the equation. Is it true? And if it is, you're good to go. Okay, so here's another example. Simple basic linear equation. 8x plus 2 is equal to 50. And so if we think of in terms of our balance, here's 8x plus 2. Here's our equal sign in the middle. And here's our 50 over here. All right. First step is to get rid of the plus 2 by the 8x, so I'm going to subtract 2 from each side. And when I do that, our resulting equation has 8x is equal to 48. Second step then is to divide both sides by 8. And when we do that, the 8's cancel out here, so we have our x. And 48 divided by 8 is 6. So we have the equation solved for x. Again, the next part's very important. Let's check it to see if it works. Is 8 times 6 plus 2 equal to 50? 8 times 6 is 48. Plus 2 is equal to 50. So it works out. We're good to go. Okay, sometimes your equations will be a little bit more involved. This one, we have a set of parentheses, so we need to remove those. And to do that, we're going to use our distributive property here. I'm going to distribute the 2 over the quantity 3a minus 5. When I do that, 2 times 3a is 6a, 2 times negative 5 is negative 10, and that's still equal to 8. Okay, so now we can start our solving process. Since we're subtracting 10, I'm going to add 10 to sort of undo it, or to get rid of it. And when I do that, my resulting equation looks like this. I have a 6a, the 10's are gone, is equal to 18. Next step then is to divide both sides by 6. And once I complete that, the 6's cancel here, and 18 divided by 6 is 3. And again, the last thing we want to do is to check this. Is 6 times 3, take away 10, equal to 8? Well, 6 times 3 is 18, and 18 take away 10 is 8, so it works out. We're good. All right, solving equations with fractions. The best thing, or probably the easiest thing to do, is to get rid of the fractions. I know how much you like working with fractions. So here's where I start. I look at these denominators, and I think to myself, if I had to add these fractions together or subtract them, what would I use for a common denominator? Well, 3 and 4 are both factors of 12. So 12 is our least common denominator. So what we're going to do, I'm going to erase this here. I'm going to multiply everything in this equation by 12. Because what that does, it eliminates the fractions. I put parentheses there to remind myself to multiply everything by 12. Don't skip any of the terms. Okay, so taking this one step at a time, when I take 12 times the 2/3 x, the 3 will go into 12 4 times, so I get an 8x. When I take 12 times my negative 1/4, 4 will go into 12 3 times, so I'll get a minus 3. And then finally, the last one, 12 times negative 1 is negative 12. All right, so there's my new equation, no fractions. Okay, so we start the process of solving then. We're going to add 3 to each side. And my resulting equation is 8x is equal to a negative 9. And last, we're going to divide both sides by our positive 8. So we end up with x is equal to negative 8/9, or negative 9/8, excuse me, which is the same thing as negative 1 1/8. Okay. All right, so checking. To checking purposes, I'm going to go back and use my improper fraction, negative 9/8, because I want to multiply it here. So let's cordon off an area here. So I have 2/3 times negative 9/8. Take away 1/4, is that equal to negative 1? All right, well, I multiply these together. 3 will go in the negative 9 a negative 3 times. 2 will go into 8 4 times, so I have a negative 3/4 minus 1/4. Is that equal to negative 1? Well, subtracting 1/4 is the same thing as adding a negative 1/4, and negative 3/4 plus negative 1/4 is negative 4/4, which is our negative 1. So it checks out. We're good. Okay, sometimes we'll have a variable on both sides of the equation when it starts off. So my suggestion here is to get the variable on the same side first. Okay? So I'm going to need to move one of these y's out of here. And it really doesn't matter which way you go. I would probably suggest trying to keep things positive, because I know you all make mistakes working with negative numbers. So I'm going to subtract 3y from each side of this equation. When I do that, then my resulting equation looks like this. I have negative 2 equals 2y plus 10. Alright, so I got the y's on the one side now, so I can get rid of the stuff around the y's. So I'm going to start by subtracting a 10. And when I do that, negative 2 take away 10 is a negative 12, and that's equal to 2y. And last step then, divide both sides by 2. And so I get negative 6 is equal to y. So again, we want to check this. Is 3 times negative 6 minus 2 equal to 5 times negative 6 plus 10. Notice I went right back to the beginning equation. Don't start somewhere else because you may have made a mistake somewhere else. So 3 times negative 6 is negative 18. And negative 18 take away 2 is negative 20. 5 times negative 6 is negative 30. And negative 30 plus 10 is a negative 20. So it works. All right. That was it. Go ahead, complete your assignment. And again, if you have questions or comments or concerns, please let me know. Thank you.